Now, when we have a normal distribution, you get a bell-shaped curve like this. And your mean goes right here in the middle. So what happens here is this little symbol right here, that little symbol means your mean. All right, this little symbol right here means your standard deviation, just so you know. So what this is saying is your mean goes here, and as you go over, that's adding a standard deviation over and over up to 3 times. And here I'm subtracting a standard deviation from your mean. You'll see that play out in a second. Now, values between 1 standard deviation below and above, there are 68% of your data will be in this space right here. Okay, 95% of your data will be within a negative 2 standard deviation and a positive 2 standard deviations from the mean. And you'll see how that plans out as we do this problem. So just be patient. It'll make more sense as we do the problem. So let's talk about this problem to give context to what I'm saying by these percentages and how many standard deviations that is from the mean. So if we read the question, a teacher has 120 students. The test scores had a normal distribution with an average of 80% and a standard deviation of 6. So if the average is 80%, are you okay? That's 80% right there. And if your standard deviation is 6, wouldn't that be, well, 86 right here? Wouldn't that be 1 standard deviation to the right? And then wouldn't it be 92? Aren't you adding 6 again? And then adding 6 again. So what I'm doing is I'm starting with 80 and I'm adding 6 or 1 standard deviation to the right. Then could I also subtract 1 standard deviation and go to the left? So if I subtract 6, that gives me 74. If I subtract 6, give me 68. If I subtract 6, I have 62. So that right there is the breakdown according to this question. And I do have 120 students, which will come in later. So what does all that mean? Well, let's answer these questions and it'll all kind of come together better. The test scores, or what test scores, are 1 standard deviation from the mean. So aren't my test scores from here to here 1 standard deviation from the mean? Isn't it from 74 to 86%? Aren't these test scores 1 standard deviation from the mean on both sides? So the next question, what test scores are 2 standard deviations from the mean? Well, isn't 2, if there's the mean, isn't that 1, 2? So 92 and 1, 2, 68. So won't it be from 68 to 92%? Won't these scores be 2 standard deviations from the mean? All right. Now let's just talk, let's go to the next question. It'll make more sense. What percent of the students got between 68% and 92%? Well, isn't that 68 and 92 right there? So what percent is this? Well, according to this bell-shaped curve for a symmetric normal distribution, what percent between 68 and here? Well, look right here. Doesn't it say right there at 95? Isn't 95% of the data going to be between those two in this bell shape? Isn't 95% of the data going to be right there? So this would be 95%. Now, what would 1 standard deviation? Let's just go back to this one. What would 1 standard deviation be? How much would there be right here from 74 to 86, 1 standard deviation? Can you tell it's 68? Even though that's not a question, I'm just want you to understand that 1 standard deviation, or 74 to 86% on these tests, there would be 68% of the students. From 68 to 92 is 2 standard deviations, which is 95%. So what percent is from 62 to 98? 99.7. Almost everybody is between these 2 grades, meaning there was no Fs. Everybody did pretty good. So, next question, what percent of the students got between 80% and 98%? So 80% to 98%. Let's look at that real quick. Let's think about that. So 80%, let's see. 80% to what percent? To 98. So from there to there, what percent of people are right there? From here to here. Well, let's think. Is 99.7 from here to here? If 99.7 is from here to here, isn't this half of it? So if I take 99.7 and take a half of that, won't that tell me how many people are in that blue section right here? Well, what's half of that? It is 49.35%. 49.35%, almost half, basically half, of the students got in this range. Actually, let me correct that. When I divided, it's 49.85. I did that wrong. Alrighty. Next question, about how many students got grades 1 standard deviation from the mean. So 1 standard deviation from the mean is right here. So what percent are in this area? Well, actually it says how many students. Well, don't you have to first find the percent to find out how many? So how many? Well, what's this green area? Isn't that 68%? But isn't that 68% of 120 students? So 68% of 120 students will give us, if you multiply that, will give you the total number of students of this 120 that are within 1 standard deviation from the mean. So this would right here be 81.6 students. Now, can I have a 0.6 students? No, it's about 82 or 81 students would be in this distribution, which is 68% of 120. All right, next. About how many students got grades from 1 to 2 standard deviations above the mean. This word above the mean is actually kind of important. If I want above the mean, between 1 and 2 above the mean, isn't that right here? Isn't that between 1 and 2 above the mean? So what percent is this little pocket? Oh, that's a little complicated. We have to think about this for a second. We have to think about what percent is that. So let's break this down a little bit better. What percent is this? Well, isn't this whole thing 68? So wouldn't that be 34% on each side? Alrighty. So then what would these two pockets be? Well, isn't it 95 for the whole thing, but isn't 68 already taken care of? So 95 minus 68, isn't that 27? What's half of 27? Half of 27 is 13.5. So this is 13.5% and 13.5%. So do I now know this little pocket? Yes. I know that pocket right there is 13.5% times 120 people. I'm going to multiply those, and I will now know how many people are in this pocket according to my 120 students. So right here we get 16.2 people, which is about 16 people. So 16 people out of 120 are in this little range. Basically, between 86 and 92% on their tests, there's about 16.2 students. All right, next one. About how many students got grades above 86. So above 86, all righty, now let's do, okay, above 86, let's see what we got here. Won't above 86 go all the way to here forever? Want to be that one now. So above 86, well, ooh, that's a little bit harder. Well, if that's 13.5, what's this little pocket going to be? Well, what's 99.7 minus 95? Isn't that 4.7? And 4.7 divided by 2, this little pocket is 2.35. Now, what is this little pocket on the edge? So, these 2% plus a very, very small percent out here. Isn't this percent going to be like half of 0.3? So what's half of 0.3? Isn't that like 0.15%? Okay, that's very small. So what percent, if I add up all those, are you okay? That is about, when you add them up, what does it look like? About 0.1585, about, plus a 1.5, so it's very small. That's times 120. I'm kind of ignoring, sorry, this last little bit. I could add it in there and make that 0.59. Okay, that's not going to change a lot. What do you get when you multiply those? You get about 19 people. That would be about 19 people. And look at, aren't those close? That's about 16. That's about 13.5. Those are close. Okay. Last question. About how many students got grades below 68? So below 68 is right here. So below 68, isn't that the same as, if I reciprocal that, isn't it just these two right here? Can you see these two numbers are going to be right here? This is 2.35 and 0.15. So be careful here. That is, when you add it together, about 0.25. Be careful with the 0, because isn't it 2.5%? Times 120. Now, could you use 2.35 instead of the 2.5%? Yeah, because that little bit's basically insignificant. When you multiply this, I think you get 3. So you should get about 3 people here. So let's rehash through this. Your mean goes here, and you move your standard deviations. Within one standard deviation is 68%, so 68% is right here, or 34% on each side. 95% between here and here, which if you broke all these down, you get 95%. And then 99.7 would be if you add up all that. And then if you want to find how many, don't you just take your percent and multiply by the population? And then we're good to go.